So our softwares are present in all the sectors of the AEC industry. In fact, when we looked at the top 10 global engineering design firms, we found that 7 out of top 10 global engineering design firms in transportation use our software. 6 out of top 10 in buildings, 9 out of top 10 in hazardous waste management. Altair's clients include small startups as well as many of the who is who in global engineering design. As more than half of the top 150 engineering firms use our Altair structural engineering solution. In fact, out of the top 10 global design firms, 7 use some of our Altair's software. We at Altair design our solutions at least to help the structural engineers to have these challenges like unknown impact of climate change on sea levels, wind speeds, temperature, etc. Sustainability, the continued search for environment-friendly processes like and materials like GFRB, timber, shrinking margins, highly fragmented AEC industry, and inadequate interoperability, so on. Our AEC solutions portfolio include code-based solutions which support national design codes such as Indian IS 456 and IS 800, which offer code-based analysis, checks, and automated design for steel, concrete, timber, and foundations. Also, it can generate automated design reports which can be submitted for rating purposes. Moving on to Altair's high-performance optimal analysis and optimized solutions, which helps our structural engineers to work outside the constraints of national design codes with products like INSPA and design exploration. Also, HyperMesh and OptiStruct, which can be used for detailed high-fidelity modeling analysis. Computational fluid dynamics for pedestrian comforts and wind loads, and also thermal analysis for HVAC applications with AccuSol and UFX, plus blast and explosion analysis, simulation analysis with radios. The game-changing meshless technology of SimSolid, which can be used for the design connections, like steel design connections. And last but not the least, math-based solutions with SCalc and Compose. Skidmore, Owings, and Merrill. This is our featured client. For those of you who don't know SOM, they are behind some of the most iconic buildings in the world. We are proud to have them as our clients, and we are indebted to them for sharing the images and model which I'll be using today as for the examples. So first example from the industry is head roof and cable wall of Mumbai Airport. So everybody would be knowing this Mumbai Airport. The roof, which covers the area of 70,000 square meter, is a 600-meter single span without any expansion joint truss. Also, it has the longest and largest cable wall system, which is around 1 kilometer approx. This head roof is supported by 30 mega columns, which are spaced in 64 meter in north and south direction and 34 meter in east and west direction, which makes a good space for our airport area. These columns were designed in such a way that there would be no need for tower cranes to be used for the construction of the roof. SOM team, they choose Altair's S-frame and S-steel for the design of this building. Also, to optimize the material efficiency and the design connections with FEA analysis, HyperMesh and OptiStruct was used. So these are some images of the model S-frame having the truss of 4 meter overall depth, and it also had the edge cantilevers of 40 meter. And another image is of HyperMesh model, which is showing the connection of column top node to the bottom roof connection. It was a very complex connection. Moving on to the usage of the material consumption, we can say. The approximate steel quantity was around 22,000 metric ton. The concrete quantity and the cost is already there. And some images of the construction of this airport roof. Also, this is the customer testimonial. Mr. Pritam Biswas, who was leading this project, he has given these words, which is already on the screen. Next, moving on to JTI headquarters in Geneva, Switzerland. This building was designed in S-frame and S-steel. The main constraint was here the front portion cantilever, which is around 30 meter. The integrated analysis and design of S-frame allows to handle complex models compared to any other competition. The Burj Khalifa Tower. Actually, S-frame was used for the initial analysis and the design alternatives because it was used because the efficiency of modeling, making changes, and running the gravity analysis. It was also used for the foundation slabs and design of piles also, which were longer than 30 meter. Antara Phase 2. It's a high-rise steel building in Mexico City. The main constraint over here was the tight deadlines of the client. Actually, to design these connections, SOM team chose Altair's SimSolid, which can design 5 times faster than any other traditional FEA softwares for the design connections of steel. Other applicants, I wouldn't want you to get the idea like our softwares are only used for the design of iconic buildings. In fact, vast of our majority of clients use for this industrial plants, design of industrial plants, roof structures, complex structures, and so on. And also for special steel structures like oil well drilling mast, Ferris wheel, mining structures, etc. So that's all from my side.